indirect measurements. So when we say indirect, let's say you want to know the height of a tree or a lamppost or a flagpole or a building, things that are really tall, like a giraffe, whatever it is. Okay, and you can't get up there and just measure from top to bottom. Okay, you can use indirect measure, creating similar triangles to measure things that you can't directly measure. Okay, so we're just going to look at different ways that you can set these up to create your similar triangles using given information to find the unknown measure. Okay, so in this first one, it says at 5 p.m., a 6-foot oak tree casts a 10-foot shadow and a pine tree casts a 7-foot shadow. How tall is the pine tree? So if we're going to use the fact that we know the height of the oak and we know the length of the shadows, and it's the same time of day, so that the angle of the sun is creating the same angle between the shadow, the end of the shadow, and the top of the tree. So because these angles are the same, they're similar triangles. Okay, so I can use that fact to identify my corresponding parts. So just like I did yesterday, I'm going to identify my corresponding pieces. So that would be the shadows correspond to each other, and then the heights of the tree correspond to each other. So they tell us that a 6-foot oak tree, so this is 6 foot, has a 10-foot shadow, and then a pine tree has a 7-foot shadow. So we are looking, this is the missing piece, is the height of the pine tree. Okay, so how could I set up that proportion? Now that I've marked my corresponding part, the next step that we learned yesterday was to set up the proportion, and then we'll use the proportion to solve. We can cross multiply, and I'm going to show y'all a Desmos trick and how you can help use Desmos to help you solve once you have your proportion set up. So I've color coded green to green, or tree to tree, shadow to shadow. How would I set up my proportion? What's one possible way? Okay, so I could do the 6 is to X. So I'm going tree to tree, oak to pine. Then what? What would the other ratio be? Say it again. 10 to 7. So because I went oak to pine, left to right, I have to go left to right again. I have to be consistent. Is this the only correct proportion? No. You could also go 6 to 10. So I could stay within the oak tree, tree to shadow, and then I would have to go tree to shadow for the pine. So 7 or X to 7. That would work also. Or if you flip either of these over, as long as you flip both, that would work also. So you'll notice no matter which way you set it up, when you go to do your cross multiplying, you're multiplying 6 times 7. And then the third number that you're dividing by is 10. So no matter which setup you did, if you did the correct, one of the possible correct setups, you're doing 6 times 7 divided by 10. Does everybody agree with that? Do y'all understand what we're doing? Okay, so now it's just type it in the calculator. But I also want to show you an alternate option. So when you go to plug this in, make sure this is only going to work in the full function Desmos. If you're going to Desmos through the SSO portal, I believe it takes you to the star testing Desmos, which has limited functionality. It doesn't let you do everything. So make sure you just go to desmos.com and select graphing calculator. It should have the black strip at the top. If you're looking at the green strip calculator, some of what we do won't work. Okay. Now, just this basic 6 times 7, and then dividing by 10, and you can do it like that, or you could do all of the 6, 7 divided by 10. It doesn't matter. You get the same thing. You get 4.2. Okay, so we get x is 4.2. So that pine tree is 4.2, and this was all in feet. So this is 4.2 foot tall. Okay, now I think I did show you in Desmos how to check your proportions. So, but this only works, it only checks that you cross multiplied correctly. If you have the wrong setup, you're still, and then you plug in what you got, it's still going to make it look like you got it right. So your setup has to be correct for this to work. But so you could check, okay, 6 is to 4.2 should be the same as 10 is to 7. Do they come out the same? They do, right? Okay, so it checks out. Now, what won't work if you're in testing Desmos is this next option of solving. Once you have your proportions set up, if you forget what to do after you have the setup, you can let Desmos do the work for you. You can type in your entire proportion. So 6 is to x as 10 is to 7. And it's going to give you a line through the solution. Now, the only problem doing it this way is that you can't click on this and get the number. It's just a visual. So the fact that it's a decimal, if this was a free response choice, like you can see it's between 4 and 5 and it's closer to 4. So you can estimate, oh, that looks like it's like maybe 4 1/4. Or when I zoomed in here, I can see that the number of squares, it's 1/5, which is 0.2. But most of y'all probably wouldn't recognize that. You would just know it's 4 point something. So if it was multiple choice, that's helpful. You can narrow it down. You know, it's 4 point something. But if there's more than one choice that's 4 point something, you may not get the right answer. Or if this was, you have to type it in and round to a specific decimal, you may not get it right doing it this way. Okay. But if it comes out as an integer, a whole number, then this way works fine. And I did want to point this out and reiterate, because on yesterday's notes, I'm actually going to pull them up really fast here. Because when we were doing yesterday's notes, here they are. On the front, on these first 4, I think everybody was pretty decent with their cross multiplying. But when we did the more complex ones that had the expressions, that algebra, that's a lot of steps, right? And if you struggle with the algebra, then you may get it wrong. Maybe you know the geometry, you know what corresponds, and you know how to set up the proportion, but you mess up in the solving. This is where that Desmos trick can really help you out, because I want you to see, if I were to type this ratio, this proportion that we set up on this complex one, 25 over 10 is to 4x minus 1 over x plus 5. Okay, I can zoom out and look for that. There's that, see that line going through my graph here? There's my solution. It's at 9. So instead of having to cross multiply and do all that algebra to get 9, like we did on the notes, you could let Desmos do that work for you. Does that make sense? So that was just the Desmos trick I wanted to make sure everybody was aware of. Okay, so let's try number 2 here. When Anaya stands 14 feet from a lamppost, her shadow is 7 feet long. Anaya is 5 feet tall. How tall is the lamppost? Okay, so let's break this down. This is that nested triangle situation that was similar to that last example in yesterday's notes. You've got the triangle created by Anaya and her shadow and the light source. So that little triangle in there. And it says that her shadow is 7 foot and she is 5 foot. So far, so good. Then it says she is standing 14 feet from the lamp. How tall is the lamp post? Now here's where you have to you don't have to, but for most of you, it's easier to separate the two triangles. 14 is not a side of a triangle, is it? If you look at these triangles side by side, if you take out that little one of Anaya, and then the lamp post and its shadow, and look at them separately, this shadow is not 14. How big is the shadow? "21. Good. Now, I would actually add more detail to this problem. It's depicted in the picture. It's trying to show you that the end of her shadow is at the end of the light post shadow. That's how we're supposed to know that's the total length of the shadow of the light post. That would really should be worded more clearly, but that's the idea of this problem. So you have to make sure that you add to get that total for that outer big triangle created by the lamp post and its shadow. So now we're looking for the height of the lamp post. So if you need to, if you don't see it, color code it, do something. We've got the height of the lamp post to the height of Anaya, the shadow of the lamp post to the shadow of Anaya. So we know what corresponds to what proportion would be appropriate here. How could I set up this proportion? I could do x over 5. And then what would that have to be equal to? Good. What's the other option? What's another way I could set this up? Instead of going green to green, pink to pink, couldn't I just go green, pink, green, pink? I could stay within the triangle. So I could go height to shadow, height to shadow. Would that work? So x is to 21 as 5 is to 7 would also be appropriate. And either way, you are multiplying 5 and 21 and then dividing by 7. See how the math is going to math the same. Okay, so you do 5, you can either plug this into Desmos like I showed you, or you can just do the cross multiplying and dividing, and that comes out to 15. So that means that the height of the lampshade or the lamp post, and this was also in feet, so I'm going to put my unit of measure, is 15 feet. So far, so good? Okay, so we've had side-by-side triangles. We've had nested triangles. Now this next one is a little different. They are using a mirror, okay? If this person stands here and they look in the mirror on the ground, they set the mirror to where from the top of their head they can see the reflection to the top of the lamppost. This creates similar triangles that are a reflection of each other. And so you can use the person's height and the distance from the mirror to each item to get the height of the item, in this case, a flagpole. Okay, so these are also similar triangles. Okay, and the distance from the mirror corresponds to the distance from the mirror. So the 8 is to the 24, and then the height of the person to the height of the item. So I'm going to put an X here because that's what I'm looking for. So I could do 8 is to 24, as 5 is to x, or I could do 5 is to 8 as x is to 24. That would work also, wouldn't it? Okay, so either way you set it up, you're multiplying 5 and 24 and dividing by 8. So 5 times 24 divided by 8 is also 15. So the height of the flag post, and these were all in meters, that M stands for meters, so 15 meters. Good? All right, so here's another tree one that's side by side. It says a 12-foot tree casts a 6-foot shadow. Then how tall is a tree that casts a 4-foot shadow? So this is similar to the first one. Actually extremely similar. They're even giving you the same pieces. So I'm going to save us some time. We're not going to, you can try that one on your own and check it later, but I don't feel like we need to do two almost identical questions. Let's look at number 5. A giraffe is 18 foot tall and casts the shadow of 12 feet. So this is also similar, but it's using different items, and let's mark what they tell us as we go. So the 18-foot giraffe casts a 12-foot shadow. Tully casts a 4-foot, a shadow that's 4 foot long. How tall is Tully? So that's actually the same also, the shadow question. You've got two similar triangles created by the shadow at the same, or the shadow created at the same time. So using the same angle. So they're similar triangles. So, I mean, we'll go ahead. I don't need to skip them all. So we'll set up 18 is to x as 12 is to 4. Or what's another way you could set this one up? Just going to color code here for it. What else could I do? Instead of going, I did height to height, shadow to shadow. What could you do instead? Yeah, you could go within the giraffe, height to shadow, and then within the person, height to shadow. As long as you're consistent, it's going to work. So you're multiplying 18 and 4 and dividing by 12. So that x comes out to 6, and these were all in feet. So that person is 6 foot. All right, last but not least, let's try one more with the mirror. So when you're using a mirror to do an indirect measure of height, the distance from the mirror to the person and to the object are going to correspond. And then the height of the person and the height of the object are going to correspond. So they tell us Wyatt places a mirror so that he can see the top of the tree in the mirror. The mirror is 3 feet from him and 7.5 feet from the tree. Wyatt is 5.5 foot tall. How tall is the tree? So what is one way I could set up a proportion here? (5.5) to x, or if I flip it, it doesn't matter, but the 5.5 to the x. And if I did 5.5 over x, what would the other one have to be? Yeah, because I went left to right. I have to go left to right. So it would have to be 3 over 7.5. Okay, and then what's it? One more option. How else could I set this up? Yeah, I could stay within the person, either 3 to 5.5 or 5.5 to 3. So I did height to distance from mirror. So I'd have to do height to distance from mirror. Either way, you're multiplying the 5.5 and the 7.5 and then dividing by 3. So 5.5 times 7.5 divided by 3. This comes out to 13.75. And these were all in feet. So that is the height of that tree. You feel okay about indirect measure? It's just kind of application word problems of what we were doing yesterday. Instead of just being given a straightforward picture, you're given a situation or scenario or information in words, and you've got to put it into a picture. Good? All right, y'all go ahead and get started. I'm going to unblock on class-wise so you can go in and start your practice. Now, I am going to go ahead. I'm going to go back for this video and go do this example 4. If you want to follow along with me, you can, or if you tried it and you want to check your answer, you can. But you can go ahead and be getting started on any of your practice. Remember, the 5.3 practice is what I would make sure is done first because it's due tomorrow. And then if that is already done, then go ahead and be working on your 5.4, which was yesterday's, or the new one for today, 5.5. Those both 5.4 and 5.5 are set to be due Sunday. So you have through this week and weekend to finish those. I just unblocked. Yeah, it was blocked while we were doing the notes. It should be open now for you to go. All right, so if you want to check number 4, follow along and do it with me, you can.
How much?
This one says a 12-foot tree casts a 6-foot shadow. How tall is a tree that casts a 4-foot shadow? So again, I would correspond shadow to shadow, height of tree to height of tree. 2 possible ways you could set up this proportion. You could stay within the big tree and go 12 is to 6. And then within the small tree, that would be X is to 4. Or you could go back and forth, left to right or right to left. It doesn't matter. But you could say 12 is to X. So that's height is to height, left to right. So then I would go shadow to shadow, left to right would be 6 is to 4. So either way that you set it up, you're multiplying 12 times 4 and then dividing by 6. So 12 times 4 divided by 6 is 8. So the height of that smaller tree is 8. And this was also measured in feet. Stop that video here. Yeah.